Welcome. In this video, we'll explore some key physics concepts which are essential in understanding how microscopes work. So we'll learn about numerical aperture or NA, magnification, resolution, useful magnification and depth of field. First up, numerical aperture or NA. So this number tells us how good a lens is at gathering light and resolving fine details. In a compound microscope, the objective lens does the heavy lifting. It collects light from the specimen, it defines how much detail you can actually see. Objectives with high numerical aperture can capture light entering from wider angles, improving image detail and resolution. The eyepiece lens simply magnifies the image that the objective creates, so it does not collect light from the sample and therefore its NA is not specified. Magnification tells us how much bigger something appears under the microscope compared to its actual size. So, total magnification is the product of eyepiece and objective magnification. For example, a 10x objective combined with a 15x eyepiece gives you a 150 times magnified view, making things appear 150 times bigger than they actually are. The microscope we'll be using for this course has a 10x and 40x objective lens and 10x and 15x eyepiece. It can be used for seeing plant and animal cells, tissues, pollen grains, yeast and more. If you have a 4x lens, it will be useful for ease of locating specimen on the slide and for seeing entire insect or a relatively bigger object or texture. Bacterial shapes can only be visualized with a 100x lens with oil immersion. These experiments raise safety concerns and are mostly not recommended for home setup. Resolution is all about clarity. It defines how well you can distinguish small details. High resolution means sharp, crisp details, while low resolution looks blurry. Resolution is directly related to NA. Abbe's formula gives us the resolution limit, which is wavelength divided by the numerical aperture multiplied by 0.61. So, for a 10x objective lens with a NA of 0.25, resolution is calculated to be 976 nanometers. Can you pause the video for a bit and calculate the resolution for a 40x objective lens? As you can see in the table, in most student microscopes, the best resolution is around 200 nanometers. This means if two points are closer than 200 nanometers apart, they'll appear as one blur, even if you zoom in more. So, you won't be able to distinguish details smaller than this limit with a standard light microscope. More magnification isn't always better. Once you exceed the resolving power of a microscope, you get what's called empty magnification, where the image gets bigger but not clearer. There's a simple rule to know what range is actually useful. Useful magnification is between 500 to 1000 times the NA of your objective. Can you pause the video again? Calculate useful magnification range of an 40x objective with a NA of 0.65. There's another question for you. Can I use a 25x eyepiece with this objective and get a clear image? So, with the NA of 0.65, the range is 325 times to 650 times. Beyond that, you are just enlarging blur. Keep in mind, most optical microscopes produce useful images only up to around 1000x magnification. So, take those 2500x claims on standard light microscopes with a pinch of salt. Depth of field or DOF will tell you how much of the image from front to back is in clear focus at the same time. So, high depth of field means multiple layers are visible at once, which is great for overall structure. And low depth of field means only one layer is sharply focused, which is good for isolating details. So, high numerical aperture lenses generally give better detail but focus on thinner slices, while low numerical aperture lenses capture broader depth but they lose the sharpness. This course is not focused on the theory of biology and definitely not on physics. But understanding these concepts will make you a more confident and skilled microscope user. If you would like to dig deeper, these websites offer great resources. In the next video, we'll learn about how to focus a slide on a compound microscope. Thank you so much for watching and keep exploring.